Good evening, everyone. Welcome to week 9, session 9 of Introduction to Biostatistics live session. I am Prashasti Pandey, PhD and PMRF Fellow from Department of Botany, Banaras Hindu University. And this is an extra session for this course, whose course instructor is Professor Shamik Sen from IIT Bombay. And if you have attended any of the previous live sessions, we solve here the questions of previous year's assignments and try to understand their concepts, which help us in solving these year's assignments. And for this case, in this an extra live session, hopefully they will help you in the upcoming exams. So we'll just wait for like 2 minutes for others to join. There are students still joining, and then we can start with the session. Okay, so let's start with the first question. I'll give you a question, and also 2 3 minutes after that, you can try solving it. If you know the answer, you can say it out loud or write it in the chat box, and then we can understand the concept and solve the question. Okay, so this is your first question. In an experiment to compare protein expression levels among three different treatments, control, drug A, and drug B using Western blot, the following sample variances were obtained. You have three treatments, and their variance and number of values and data sets are given, and you have to calculate the pooled variance for this. You can try solving this question, and then we can understand the concept and solve it. Okay, so let's try solving this question. So in this case, the values that we are given is the variances and the sample size of all the three treatments that we have, that is control, drug A and drug B. So now to calculate the pool variance, we have a formula where you need the ni minus 1 value into the variance and then summation of all the ni minus 1 value. So now to calculate this thing in this huge formula, what we can do is we can simply calculate the individual values all at once and then put them inside the formula. So let's first try to solve the numerator and then the denominator. So in this case, for control, the n value is suppose 5. So n minus 1 will be 4 and the variance is also 4. So for this entire thing, for your first treatment, the value will be 4 into 4, which is 16. Similarly, for drug A, your n is 5. So 5 minus 1 is 4 and your variance is 6. So 6 into 4 will be 24. And for drug B, your n is 5 and 5 minus 1 is 4 and 4 into the variance is 8. So 8 into 4 will be your 32. So these are the values of n minus 1 into variance for each group. Now we simply have to put all these values inside the formula, dividing by the summation of n minus 1 values. So the summation of numerator, as we calculated in the previous slide, was 16 plus 24 plus 32 will be your 72. Okay, so this is the summation for the numerator. Now for the denominators, you just have to subtract 1 from all the n values that are there. So all the n values in this question were 4 and minus 5 and minus 1 will be 4. So 4 plus 4 plus 4, answer is 12. Now it becomes very simple. You just divide 72 by 12 and then your answer is 6. So the pool variance for this question will be 6. Okay. So your option A is correct. I hope this question was clear. We can move on to next question. TSS is, there are four options. 2 in bracket SSR plus SSE, SSR plus SSE, 2 SSE plus SSR and SSR plus SST. Okay, so let's try to solve this question. So let's first understand what TSS is. So TSS is nothing but total sum of squares. Okay, so total sum of squares is a statistical measure that will quantify the total variation in the observed data. So basically understand it in a way that it will show how much the individual observation will deviate from the overall mean of the data. Okay, so this is what the definition of TSS is. Now, by definition, it is calculated as the sum of square differences between each observation and overall mean. Okay, so this is the formula for sum of square of means. Okay, SSS total will be summation of xij is the individual observed value for any observed value, and x bar is the mu. Okay, so this is the summation of square will be your sum of square of total. In this case, the it is written that treatment of j in I block, it is an example of randomized block design. Okay, so this summation will it will basically run overall observations in all the blocks and in all the treatments. Now, with this, the question was asking that how much variation is there in a data as whole. So now in designing any kind of experiment, there can be different types of sum of squares. Okay, so sum of square one can be sum of squares due to treatments. Okay, so this means that how much of variation is explained by differences between the treatments. So if your observations, if there are multiple treatments in the observation and there is any sort of variation which is occurring due to the treatments, that that variation will basically be called as SSTR, or sum of squares due to treatments. The second one is sum of squares due to blocks. So this kind of variation will be explained by differences between the blocks. So in case of randomized block designs, where there are different blocks and different treatments within that block, so the variation in the data due to different blocks will be called as sum of squares due to blocks, or it is also called as SSB. The first one was called as SSTR, and the third one is sum of squares of error, or error sum of squares, which is also called as SSE. So SSE will be the variation which is unexplained. So in case of randomized block design, there is one single block and there are multiple treatments inside those blocks, and there are multiple such blocks. So your total sum of squares will be, first, the error that is arising due to the treatments in every block. Second, the variation arising due to different blocks. And third will be if there is some variation that is unexplained, neither by the variation in the block nor by the variation in the treatment. So that will be called as SSE. Now, that means that our SS total will be the sum of SS of treatments, SS of blocks, and SS of errors. Right? So, in case of ANOVA or regression, the total variation in the data is all, because there is no block in that. The total variation of the data will be variation explained by regression or due to so in case of regression, SSR will be arising due to regression or due to, depending on what model we are using, any variation arising due to that model will be SSR, and any explanation, any variation which is unexplained will be SSE. So in that case, total variation of the data will be SSR plus SSE, that is variation due to that model and an unexplained variation. So total variation will be the sum of variation explained by the model. It could be any model that we are using, and the variation that cannot be explained. Okay. So now according to this, our answer will be TSS is SSR plus SSE, which is your option B. Okay. I hope this was clear. We can move on to our next question. Which of the following experimental scenarios would benefit from using a randomized block design? Your options are population A, population is large; B, population is highly heterogeneous; C, population is reasonably homogeneous; and D, population can be grouped into subpopulation. So let's solve this question. So, as I was explaining in previous question that what a randomized block design is. So basically, an RBD or a randomized block design is an experimental design that is used to basically control for known sources of variation. Okay, so when among different experimental units by grouping them into a homogeneous blocks. So if there are different treatments that we are trying to see, okay, so to control the because there are different treatments, there are chances of high variation. So to control the variation, because we know the sources of variation is due to a large number of treatments. Therefore, what we do is we make blocks of different treatments which are also randomized, and then make multiple such blocks. So what this will do is this will regulate the variation that might arise due to different kinds of treatments. So it is especially useful when factors other than the treatment might influence the outcome. So, what are the key features of randomized block design? So, first is blocking. That experimental units are divided into blocks based on a factor. So, that might influence the response variable. For example, there can be a block of people of different age, or there can be a field of different types of soil, or there can be a location, a specific location which has different kinds of things. So, let's take an example of soil. So, if you have a field which has multiple types of soils, and the growth of the plant is affected by the type of soil, so that will cause more variation. So plant growth will be affected by the soil type, and that will lead to variation. So in case of randomized block design, what we will do is create a block and then randomly put that soil and then grow plant on it, so that the plant growth is not affected by the variation due to the type of soil. Then second one is randomization. That within each block, the treatments are randomly assigned to ensure the unbiased results. So let's take the example of soil type. That in case of a small block, different kinds of soils will not be placed in same order. It will be randomly placed inside that block in different blocks. So this will not lead to biased results. So it is not like suppose A soil is placed on the left corner and C soil is placed on the right corner in every block. No, there are chances that A is placed on the left corner and then in other block it is placed on the down right corner. So this will not, so there will be no biasness in the result in a way that we say that this particular plant is growing here more because red soil is on the left side. Okay, so to remove this kind of biasness, there is a randomization within the block as well. Now, the third feature is homogeneity. Now, homogeneity word here will be that because the units within a block are similar, it will reduce the variability within the block. And therefore, it will improve the accuracy of the treatment comparison as well. This is called as homogeneity. And the fourth one is comparison within the blocks. So now because different treatments among different differences among the treatments are compared within the blocks, this will help control for the block effect. So because there are different treatments in the block and there are multiple such blocks, so the differences in those blocks can be calculated and it can be controlled. The effect of that can be controlled. So these are the four important key features of randomized block design. Now let's understand this by example, that if someone is studying the effect of different fertilizers on a plant growth. Okay, so the problem is different kinds of soils across the field. Now the solution can be that group the fields into block based on the soil types, and within each block randomly fertilizers will be assigned. So the problem here is soil type. Okay, so so if suppose there is a square field and then there are four types of soils at different corners. Okay, so and we have to study the effect of the fertilizer on the plant growth. Now adding the fertilizer on soil A and adding the fertilizer on soil B can cause different effect, and you will not know that whether and you will not know that whether the effect is due to particularly the soil or it is due to the fertilizer. So in that case, what can be done is that we will make those soils as individual blocks and then assign the fertilizers to them randomly, and then analyze the effect of the fertilizers while controlling the differences due to soil type. Okay, so basically RBD can be used when you group the experimental units into blocks based on similar characteristics that may affect the outcome. And then blocking will help control the variability caused by known factors, and each block is relatively homogeneous internally, but the blocks may look different. So this design is mostly useful when the group of population, when you can group the population into subpopulation and still they are expected to differ. So, according to this, the question answer to our question that experimental scenarios would benefit from using the randomized block design, the answer, your answer D is correct. That population can be grouped into subpopulation, and this is the benefit because you're taking a whole field and still creating blocks within them, and then randomly adding things to that. So that is creating a subpopulation within a population. So that is how what one of the main benefits of randomized block designers. Okay, I hope this was clear. Let's move on to our next question. In a study examining the relationship between the concentration of neuraminidase and the response of diabetic wound healing, the following regression equation was derived from the data y equals to 980 minus 0.5x to see how x and y are related. So the question is how in this equation is x and y related? Whether they are independent and non-related, have a negative correlation, directly correlated, or exponentially correlated. Okay, so let's try to understand this question. So let's first understand what regression analysis is. So regression analysis is basically a statistical technique that is used to understand the relationship between one dependent variable and one independent variable. Okay, so there has to be one dependent variable which is basically an outcome, which is, so dependent variable is the one that is happening due to the other variable. Okay, and the independent variables can be one or more independent variables, which are basically the predictors or the explanatory variables. Okay, so independent variables will basically help you predict or explain or model how the changes made in independent variable will influence the changes on the dependent variable. So now on basis of this, the key goals of regression analysis will be: first is prediction, that is to estimate the value of dependent variable based on the known values of the independent variable. Then second will be explanation, that is understanding how changes in predictors will affect the outcome. And third will be modeling relationship, that is quantifying the strength or the direction of the association between the dependent and the independent variable. Now, there can be three different types of regressions. One is called as simple or linear regression, where independent variable, when there is one independent variable and one dependent variable, then it is usually used for simple linear regression. So now the example can be y equals to a plus bx, which is equation for the line. Okay, where y is your dependent variable, x is an independent variable, a is the intercept, and b is the slope or the coefficient. Second, there is a multiple regression, where there is more than one independent variable, in which case the equation will change to y equals to a plus b1x plus b2x plus so on and so forth. The third one is a nonlinear regression. In this case, the relationship can be either exponential or logarithmic, but not linear. So now, according to our question, the equation was y equals to 980 minus 0.56x. So here, y is your dependent variable, 980 is your intercept, minus 0.565 is the slope, and x is your independent variable. Okay, so when the intercept is when intercept value is 980, which is, and x is 0, then in that case y equals to 980, and the slope is minus 0.56 565. So that means that for every 1 unit increase in x, y will decrease by 0.565 units. That means there is a negative relationship. Negative relationship will always uh, cause the dependent variable to decrease when the independent variable is increasing. So then, according to this, the regression equation that we have, the coefficient of x, which is minus 0.565, is a negative coefficient, and this means that on increase of x, the y will decrease, which will lead to a negative correlation. So the answer to this question is a negative correlation. Now let's move on to our next question. What is variance of ax plus b equals to? Our options are variance of ax plus b, a into variance of x plus b, a square into variance of x, and a into variance of x. Okay, so let's try to solve this question. So variance is a measure of how much values of a random variable, which is x, will differ from its mean, which is represented by mu x. Okay, so this is the definition of variance, that if there is a variable x and which is a part of a data set, and the mean of that variable will be mu x, then how much difference is there between the mean mu x and the variable x is called as the variance. Okay, so if you write it in the form of formula, then in that case it will be written as variance of x will be equal to e in bracket x minus mu x square. Okay, where e is the expectation that will lead to variation, and the mu x will be the mean of the x variable, and x is our variable. So now in the variance formula, it has this property that if you add a variable a within the variance formula and a variable b, then it will the value will be equal to a square into variance of x. Now why will this happen? So basically, when you are multiplying a random variable x by a, that means it will be scaled a times, so its variance will be squared by a times. Okay, but when you went to that same variance of x, if a constant b is added, it will not affect the variance, because variance measures the spread of the data and not location. Okay, so that means that to a variance, if any value is added, as in the location of addition, that will not affect the variance at all, because that will only change its location. Okay, and because variance is not affected by the location but it is affected by the spread of the data, it will not cause any changes. On the other hand, if a random variable is multiplied to the variance, in that case the variance will be scaled to square of that particular variable it is being multiplied by. So in this case, our a is basically multiplied by the x variable, okay, and b is added. So according to this definition, we are saying that when something is multiplied to the variance, the change will be square times of that. Okay, so it will be a square of the variance, but adding b will not make any changes. So then the question that was asked was, what will be variance of a x plus b? So the answer will be a square into variance of x. Now, how to understand this? That multiplication of a. So basically, if you multiply a random variable, suppose a in this case, then by a scale, the variance will spread by a square. That is why variance involves a square and not just a. But adding a constant b to every value in the data set will basically shift all the values, but will not change how spread out the data is. Okay, so if we try to put this in easy language, suppose if you have a data set of values 1 2 3 4, okay, and you calculate the mean of that, and then you calculate how far 4 is from that mean. Okay, now you create another data set where you add 1 to all the numbers in this data set. So the other second data set will have 1 plus 1, 2 plus 1, 3 plus 1, and 4 plus 1. Okay, so whatever mean you have of the second data set, that mean and the difference between the last variable, for in this case 4 plus 1 will be 5, So the distance between the mean and 5 from the second data set and the distance between the mean and 4 from the first data set will not vary. So that is why addition of any variable like b will not affect the variance. But if you multiply the random variable, then in that case the variance will change by square of its value. Okay, so this is the property of variance. So here it is given by an example that if x has a variance of 4, okay, and a is 3 and b is 5, that means b 4 if 4 is added, 5 is added to the values and 3 is multiplied, so the variance of 3 into x plus 5, so 3 x so if you square, so that will be equal to your a square plus into variance, right? So your a square is 9, 3 a is 3 here, so your a square is your variance will be equal to 3 square into 4. 4 is the variance. So it will be 36, which means that adding 5 did not matter. But multiplying it by 3 will increase the variance by 9 times. Okay. So according to this question, our answer will be that variance of ax plus b will be a square into variance of x, which is your option C. I hope this question was clear. Let's move on to our next question. Calculate the value of variance in an experiment of single dice. Okay, so let us solve this question. So the question is asking about calculating the variance in an experiment of a single dice. So variance means it is so what we need to do is we need to calculate a mean value of all the outcomes that a single dice will have, and then what could be the variance of every outcome of the single dice. Okay, so now first we need to calculate the mean of it, right? Because then only we can calculate the variance. So how to calculate the means? A fix. We need to have the data set values, right? So here, now suppose a fair dice. Okay, fair dice will basically have only six outcomes, right? The question is talking about a single dice. So the single dice in one throw can have only one of the six outcomes, right? It can be either one, two, three, four, five, or six, and this is our data set here. Now, the probability of each outcome is, of course, it will be 1 by 6, because when a single dice is thrown once, there is only a possibility of one single number showing up on the dice out of the 6. So, the probability of every number showing up will be 1 by 6, right? Now, if we have to find the mean of it, this is our data set. So the mean formula will be simple. We will have to add all these values and divide it by total number of values, which is 6. So now it will be 21 by 6, which is 3.5 will be the mean value of all the data points of a single dice. Now we need to find the variance. So the variance formula is expected value into the x value, the value of each dice minus the mean and square of it. Okay, so this means we'll calculate the square deviation of each value from the mean and then multiply its probability and then sum it. Right. So now we will just create a small table for it. So now we have six outcomes, 1, 2, 3, 4, 5, 6. And we know that the mu value is 3.5. Okay. So now what we simply have to do is we have to subtract each value, we have to subtract 3.5 from each value, which will give us x minus mu. So if our dice one value is 1, then 1 minus 3.5 is minus 2.5. Similarly, 2 minus 3.5 is minus 1.5. Then 3 minus 0.35 is 0.5. 4 minus 3.5 is 0.5. 5 minus 3.5 is 1.5. And 6 minus 3.5 is 2.5. And now we will have to square all these values, which will give us x minus mu square, which is this value. Okay. So now once we have x minus mu squared values, then it is simple to calculate the variance. Okay. So variance will be probability and the sum of all this x minus mu values here, right? So E is our expected outcome, which is 1.6. And then we will multiply all the values here, which was in our previous outcome. Okay. So now it will come as 1 by 6 into 7.5, which will give us the answer as 2.9167. So the variance of x will be 2.917 in this case. So our option C will be correct. Option 2.917 will be the variance in an experiment of a single dice. So let's move on to our next question. What will be the expectation of a binomial random variable x with parameters m and pb? Okay, so let's solve this question. So a binomial random variable x with parameters m, that is number of trials, and p will be the probability of success in each trial. Okay, so now the expected variable variance of x will be, so basically the question is simply asking about that what is the expectation of a binomial random variable x with parameters m and p, right? So the expectation will be simply m multiplied by p. So you can understand this by this example, that if you are performing m independent trials and each trial has a success probability of p, then the total number of successes will be the number of independent trials multiplied by the success probability in each trial. So it will be simply m times of p, which is equals to m into p, which is your answer, which is option D. Right? Option D is correct here. Okay, so the next question is the expectation and variance of a random variable x of a Poisson distribution are. Okay, so to solve this question, let's understand first that what is Poisson distribution. Okay, so Poisson distribution is basically a discrete probability distribution that expresses the probability of a given number of events occurring in a fixed interval of time or space. Okay, so when these events happen with a known constant mean rate and independent of time since the last event happened, then in that case we use a Poisson distribution. So now what are the key characteristics of this distribution? First is that it is a discrete distribution. That means it will deal with the countable events such as number of emails received in an hour or number of cars passing through a checkpoint in a day. So these are basically, you can count them. So they will always be a, so they will always be discrete events. Okay. Now, second will be that there will be the distribution will always depend on a single parameter. Okay, which is the average rate of occurrences in an individual. Right. Third will be that all these events are independent. That means the occurrence of one event will not affect the occurrence of another event. And then fourth will be that events will happen at a constant rate. That is, lambda will remain constant across all the intervals. So now, according to the question, if a random variable x will follow a Poisson distribution with parameter lambda, then the expectation will be equals to, then that means in case of Poisson distribution, the mean expectation will be lambda and the variance will also be lambda. Okay. So this is the property of Poisson distribution. Now, so this means basically that this is a defining feature of Poisson distribution, that its mean and variances will be equal. So you can understand this by some examples like number of phone calls received by a call center in an hour, or number of accidents in a traffic jam in a week, or number of mutations in a given strand of DNA, or number of decay of events from a radioactive substance in a second. So the answer to this question will be that expected mean of x will be equal to the variance of the x in case of Poisson distribution. So your option D is correct. Okay, so let's move on to next question. Which of the following distributions is considered memoryless? The options are normal, exponential, uniform, and geometric. So let's solve this question. Let's first understand that what is a memoryless property. So the distribution will be memoryless if the probability of an event occurring in the future is independent of what has occurred in the past. Okay, so in mathematical terms, for a random variable x, the memoryless property will mean that the given event has survived up to times s, and the probability, okay, and the probability of it surviving an additional t units will be the same as the original probability over t. Okay, so that is memoryless property. Now, which distributions are memoryless? So there are two distributions considered memoryless. One is exponential distribution and the other one is geometric distribution. But exponential distribution is memoryless for a continuous random variables, whereas geometric distribution is memoryless for discrete random variables. Okay, so discrete, I hope everyone knows the difference between discrete variables and continuous variables. Continuous variables are the ones whose values can also come in decimals, as long as very small values. But the discrete random variables will always be a whole number. Okay, the values will never be point. For example, the number of students who have passed out of 10 will be 5 or 4 or 3. It can never be 3.5 or 3.2. Okay, but the average height of a class can be 13.2 or 14.2. Right, so in this case, average height of class is a continuous random variable, but number of students passing is a discrete random variable. So geometric distribution for these kind of variables will be memoryless, and in case of average age, the exponential distribution will be memoryless. So according to our question, both exponential distribution and geometric distribution can be right answer. But if it is asking about continuous distribution, then in that case, the answer will be exponential. Okay. Okay, so I hope this session was helpful for you. And if there are any questions that you want to ask or anything, please let me know. Otherwise, we can end this session.